Mars is not holding still. In 1976, NASA's Viking orbiters photographed a patch of ground in the largest basin on Mars. In 2024, the European Space Agency photographed the same ground again. Between those two frames, a blanket of dark volcanic ash has walked at least 320 kilometres south, about 6.5 kilometres every single year, on a planet we call geologically dead, and when the agency published the comparison this April, it admitted it cannot say whether something is arriving or something is being taken away. This is the story of a shadow nobody can explain. The assumption we made about Mars is that it finished, that whatever Mars was going to be, it already was some 3 billion years ago, and everything since has been the slow settling of dust onto a corpse. The European Space Agency put that assumption into a single sentence when it published the image this story is about. Noticeable change on Mars, they wrote, often takes millions of years. Then they showed us the exception. The image arrived on the 15th of April, 2026. It was captured 2 years earlier by a camera aboard an orbiter that has been circling Mars since 2003. What it shows is a scene split cleanly down the middle. On one side, the Mars everyone carries in their head, bright, tan, dust-covered sand. On the other side, something dark, not shadowed, dark. A blanket of volcanic material lying across the ground with a visible edge where it meets the light terrain, like a tide line on a beach. By itself, that is a photograph. What makes it a story is that we have another photograph of the same ground, taken 50 years earlier, and in that one, the dark material does not reach nearly as far. Something in the largest basin on Mars has been moving. It has been moving for at least half a century. It has covered a distance you could not walk in a week. And the agency that took the picture has been explicit about the part that matters most. They do not know which of two opposite processes is responsible. Before we can understand why that admission is more unsettling than a mystery, we have to go back to the last time a dark region on Mars appeared to spread. Because we have been here before, and we got it spectacularly wrong. Long before there were spacecraft, there were people at eyepieces drawing what they saw. Camille Flammarion published 2 volumes on Mars in 1892, cataloguing its markings. Gérard de Vaucouleurs did the same in 1954. Across that entire span, observers kept reporting the same strange thing. The dark and light patterns on Mars, what astronomers call albedo features, the planet's reflectivity map, were not fixed. They changed shape. They changed darkness. Sometimes they seemed to move. The most famous version of this was called the wave of darkening. Each Martian spring, as the polar cap shrank, large dull regions were reported to deepen in tone, some observers describing a greenish cast, with the change spreading from the pole toward the equator over a matter of weeks. There was an obvious explanation, and it was intoxicating. Vegetation, plant life waking with the season, watered by meltwater running from the retreating cap, greening the plains of another world on a schedule. In 1967, James Pollack and colleagues laid out the 2 live options honestly: biological growth or the redistribution of fine dust. Then Carl Sagan and Pollack worked the problem and took the beautiful answer away. The darkening was wind-blown dust. Mariner 9 flew a deliberate observing campaign in the early 1970s, specifically to track these variable features, and the dust interpretation held. Charles Capon went one step further and argued the wave of darkening was not even a darkening. It was a wave of brightening. The dark regions had not changed much at all. The bright deserts beside them had, and our eyes had read the contrast backwards. That is the inheritance this new image lands into. The last time a dark region on Mars appeared to spread, the exciting explanation was wrong, and the boring one, wind-moving dust, was right. Which is exactly why what is happening in Utopia Planitia deserves your attention. Because this time, the boring explanation is the one we cannot pin down. Utopia Planitia is the largest impact basin on Mars. It is roughly 3,300 kilometres across, just under twice the north to south extent of the Sahara Desert. Something enormous hit Mars a very long time ago and left a bowl you could lose a continent in. That bowl did not stay empty. Utopia Planitia is thought to have held standing water, possibly a lake, possibly an ocean. Today it is filled with rock and sand, but a great deal of water is still there, locked underground as ice. Features across the terrain still carry the marks of water that once flowed. This is also one of the most closely watched places on the planet, and that is an accident of history. In 1976, NASA's Viking mission arrived at Mars. Viking 2's lander touched down in Utopia Planitia on the 3rd of September that year and ran a series of biology experiments, the first serious attempt to test Martian soil for life, continuing until it fell silent in 1980. Overhead, the Viking orbiters photographed the surrounding ground. Those orbiter frames are the baseline. They are the reason this story exists at all. In the Viking images from 1976, the dark material in this part of Utopia Planitia is present. It is simply smaller. Its southern edge sits well north of where that edge sits now. Nobody in 1976 flagged this as significant, because nobody expected to need it. You do not take a before photograph when you do not believe there will be an after. 50 years later, those frames became the first half of a measurement, and the second half came from a camera nobody expected to still be working. Mars-Express launched in 2003. It is a European Space Agency orbiter, and it carries 8 instruments, one of which is the high-resolution stereo camera, usually shortened to HRSC. That camera was built and is operated by the German Aerospace Center. Its data is processed at the Institute of Planetary Research in Berlin-Adlershof, and the image products released in April of 2026 were produced by the Planetary Sciences and Remote Sensing Working Group at the Free University of Berlin. For more than 20 years, that single camera has been mapping Mars in color and in 3 dimensions, quietly outliving every expectation placed on it. And the method behind this discovery is almost insultingly simple. There is no model here, no statistical retrieval, no inference chain that a skeptic can pull apart. You take a photograph of a piece of ground. You take another photograph of the same piece of ground 50 years later. You line them up, and you look at where the edge is. That is it. That is the entire measurement, which is why it is difficult to argue with. Most of what we know about other worlds arrives wrapped in layers of interpretation. Spectra fitted to models, light curves inverted into shapes, signals dug out of noise. This is a before and after photograph. A child could see it. The dark ground reaches further south than it used to. The only question is, how much further? And the answer to that question is the number that turns this from a curiosity into something harder to sit with. Sections of the southern boundary of the dark deposit have moved south by at least 320 kilometres. Say that number out loud, and it stays abstract, so anchor it. 320 kilometres is roughly the distance from London to Paris. It is roughly the drive from Los Angeles to Las Vegas. If you set out walking at a decent pace and did nothing else, it would take you about a week. That boundary crossed that distance in 50 years, which works out to an advance of somewhere around 6.5 kilometres, about 4 miles, every single year. Think about what that means on a planet we call geologically dead. 6.5 kilometres a year is not a geological rate. 6.5 kilometres a year is a rate you could observe. A person who arrived on Mars as a child and lived an ordinary lifetime could watch that edge cross the horizon. There is an honest limit to state here. The total size of the dark patch has not been published. What has been measured is the movement of one boundary, the southern one, between 2 known dates. And there is a second limit. Two photographs, 50 years apart, give you 2 points. They do not give you a curve. That 6.5 kilometre annual figure is an average, and an average is a very good disguise. It could describe a steady creep, a slow, uniform tide, or it could describe a planet that sat almost perfectly still for decades, and then did the entire 320 kilometres in a handful of catastrophic dust storm seasons. We cannot currently tell those two histories apart, and we cannot tell what the dark material is doing either, only what it is made of. Here is where the story could go badly wrong, so let us be precise. The dark material is volcanic ash and volcanic rock. It is loaded with what geologists call mafic minerals, minerals that crystallize at high temperatures. Olivine and pyroxene are the two names that keep appearing, and they are the reason the deposit reads as dark rather than ochre. These are the same minerals that darken basalt terrain on Earth. There is nothing exotic about them. That material was made by volcanoes, and it was distributed by eruptions that happened millions of years ago, back when Mars was volcanically alive. Mars still carries the monuments to that period. Olympus Mons, the largest volcano in the solar system, standing more than twice the height of the largest volcano on Earth, is still sitting there, extinct, on the same planet. So the substance itself is ancient and inert. Nothing is being manufactured. No vent is open. Nothing is erupting. This matters because a claim circulates online, and it circulates every time an image like this is released, that the dark shapes on Mars are artificial, or biological, or evidence of something being covered up. The composition answers that directly. It is ash, we know which minerals. We have known for a long time. And it is worth remembering that the one-time a spreading dark region on Mars was widely attributed to living things. That hypothesis was tested, and it failed. But notice what the mineralogy does not tell us. Knowing what the material is made of tells us nothing about why it is moving. The ash stopped forming millions of years ago. The ash is a fossil, and the fossil is walking. Every explanation for a moving deposit on Mars requires the same thing: wind. Wind to lift it, wind to carry it, wind to strip whatever lies on top of it. Which raises an awkward question. How well do we actually know the Martian wind? Until last year, the honest answer was badly. Our picture of Martian weather came from a small number of landers and rovers sitting at a handful of points on a world with the land area of Earth. Everything else was model. Then, on the 8th of October 2025, a team led by Valentin Bickel at the University of Bern published a study in Science Advances that changed that. They trained a neural network to recognize dust devils, the tornado-like whirlwinds that wander the Martian surface, and set it loose on 20 years of orbital imagery from Mars-Express and from the ExoMars Trace Gas Orbiter. The result was a catalogue of 1,039 dust devils, and for the first time, their speeds and directions of travel. Bickel put the idea plainly. Dust devils, he said, make the normally invisible wind visible. By measuring their speed and direction of travel, the team had started mapping the wind all over the surface of Mars, something that had been impossible before, because nobody had enough data to attempt it globally. The method is the part that should make you smile. Both spacecraft build a single image by stacking separate channels, taken a designed fraction of a moment apart. If the ground is still, that delay causes no problem. If something is moving, it smears into slight colour offsets, an artifact, a flaw, the kind of thing you normally correct away. Those offsets were the measurement. In Bickel's words, they turned image noise into valuable scientific measurements, and the number that came back was higher than anyone had planned for. Near surface winds up to 44 metres per second, 158 kilometres an hour. Faster than any rover on the ground has ever recorded. More importantly, in most cases the dust devils were moving faster than current Martian weather models predicted. Connect that straight back to Utopia Planitia. Both explanations for the growing dark patch depend entirely on wind doing the work over decades. This is the first global measurement of that wind, and it came back stronger than the models that were supposed to tell us how fast the ash could possibly travel. Picture yourself there at the edge, where the bright ground meets the dark. The line is not sharp when you are standing on it. From orbit it looks like a coastline. Up close it is a gradation. Tan sand thinning, darker grains showing through. The ratio shifting under your boots over a few hundred meters, until you are walking on ash. The sky above you is not blue. It is a dull butterscotch, hazed with suspended dust that never fully settles. Because there is no rain on Mars to wash the air. Your shadow is soft-edged and weak. The sun is a smaller disk than the one you grew up with, and the wind is blowing at 100 kilometres an hour. You would barely feel it. That is the part that breaks intuition. The Martian atmosphere is around 1% as dense as the air at sea level on Earth. A wind that would flatten a fence at home arrives here as a thin push against your suit, a faint hiss, a pressure you would have to concentrate to notice. Nothing gets knocked over. Nothing gets torn away. But it does not need to. It only needs to lift grains of dust smaller than the ones in the air of a dry room, and then carry them, and then do it again tomorrow and the day after for 50 years. That is the scale mismatch this whole story turns on. A force too weak to move you is repainting a region larger than a country. Now stand still and ask the question the people who took this photograph cannot answer. Is the ground beneath your boots dark because ash arrived here, or because something bright was taken away? The agency's own words are worth quoting exactly, because the framing is unusually candid. The spread of the ash over the last 50 years, they wrote, has two possible explanations. Either it has been picked up and moved about by Martian winds, or the ochre dust that previously covered the dark ash has been blown away. And then plainly, there is currently no clear evidence as to which is correct. Read those two options again, because they are not variations on a theme. They are opposites. In the first, dark material is arriving. Ash is being lifted from where it lay and deposited somewhere it was not, and the boundary is a front of new sediment advancing across the plain. In the second, nothing arrives at all. The dark ground was always there, buried under a thin coat of bright dust, and what is moving is the covering, being peeled back, exposing what was underneath the whole time. The boundary is not an advance, it is an unveiling. These imply different amounts of material in motion, different wind regimes, different histories for the ground beneath. In one, Mars is building something. In the other, Mars is undressing. 50 years of continuous observation. A stereo camera in orbit for more than 2 decades. The most studied basin on the planet. And the field cannot yet separate adding from removing. That is not a failure of anyone's competence. It is a statement about how thin our coverage of another world really is, even the world we have studied hardest. But there is a reason to care about the answer beyond curiosity, and it is the finding that turns this from a puzzle into something with consequences. In April of 2007, 3 researchers published a paper in Nature that most people have never heard of and that reframes everything above. Laurie Fenton, of the Carl Sagan Center, Paul Geissler, of the United States Geological Survey, and Robert Habel of NASA's Ames Research Center asked a question that sounds trivial and is not. Does changing the color of a planet change its climate? The context was already established. 2 years earlier, Geissler had published a survey comparing modern orbital images against Viking and Mariner 9. His finding was that more than 1/3 of the surface of Mars has brightened or darkened by at least 10% across 3 decades. Across the wider record, up to 56 million square kilometers of Martian ground has been observed to change reflectivity by 10% or more. For scale, the entire land area of Asia is about 44.5 million square kilometers. So this is not a local oddity. Utopia Planitia is simply the clearest photograph of a process running planet-wide. Fenton, Geissler, and Habele ran the changed albedo through a Mars general circulation model. The results are the reason this story does not end as a curiosity. Darkened ground absorbs more sunlight. Warmer ground warms the air above it. Warmer air moves faster. Their model predicted enhanced wind stress in recently darkened areas and reduced wind stress in brightened ones, which means the colour change strengthens the very winds that produce the colour change. It is a loop that feeds itself. The model also predicted a net annual warming of Martian surface air temperature of about 0.65 Kelvin and increased dust lifting by both wind stress and dust devils, which may bear on how Mars triggers the planet-encircling dust storms that occur nowhere else in the solar system and that we still cannot predict. It even predicted warmer southern summers, consistent with the steady retreat observed at the scarps of the South Polar ice. So the dark patch is not a stain on a static world. It is one visible node in a system that is amplifying itself, and we found it by accident in the margin between two photographs. Look closely at the same image, and the dark blanket turns out to be hiding company. There is an impact crater sitting inside the ash, about 15 kilometres across, ringed by a bright collar of material thrown out when it formed. Inside it are squiggling lines that mark where icy material has crept about within the crater walls, ice moving slowly under its own weight. In the lower right, in the ash itself, there are rounded pits with wavy edges. They are called scalloped depressions, and they are very common in this part of Mars. They form when ice below the surface melts or escapes into the air, leaving the ground above unsupported until it collapses. They do not appear alone. They merge, joining into larger and larger areas of subsidence. They tell you this terrain is periglacial, cold climate ground packed with buried ice, cycling through freezing and thawing. And on the bright half of the scene, cutting across the sand, are grabens, ditches around 20 kilometres long and 2 kilometres wide, meeting to form a giant rounded figure. Grabens form when a surface cracks, either along weak points in layered wet sediments or under tectonic strain. So take stock of this single frame: a blanket of ash advancing across the ground, a crater with ice creeping inside it, a field of pits where the ground is falling into the space its own ice used to occupy, a labyrinth of fractures where the crust has pulled apart. Every one of those features is a process, not a monument. Not one of them is finished. We called this planet dead because the only motion we could detect was slow enough to ignore. That was never a fact about Mars. It was a fact about how long we had been watching. So where does this leave us? It leaves us with a 50-year photograph of a boundary that has walked at least 320 kilometres, made of ash that stopped forming millions of years ago, driven by winds we only learned to measure last year and which turned out to be faster than our models said, on a planet whose changing colour is quietly steering its own climate through a loop that reinforces itself. And with the people who own the best cameras in Martian orbit saying, in public, that they cannot yet tell whether something is arriving or something is being taken away. That last part is the thing worth carrying out of this. We are extremely good at building instruments. We are extremely good at holding a camera steady across 2 decades and 100 million kilometres. What we are not good at, and have never been good at, is being present. 50 years of watching Mars produced 2 usable frames of this particular ground. 2. Everything between them is inference. The dark material will keep moving while you sleep tonight. It will move about 18 metres by this time next year, a length you could pace out in a car park. And it will do that again, and it does not require our attention to continue. I think that is what unsettles me most about this image. Not that Mars is changing. Planets change. It is that Mars has been changing at a visible rate, in the open, in a basin we landed in, photographed and declared understood. And we only noticed because someone thought to line up an old picture with a new one. The universe does not hide most of its strangeness. It just moves at speeds we forgot to check for. Thanks for watching, and I'll see you in the next one.